Thank you very much, Joao. The pleasure is mine. Let me confess that sometimes for someone who works in tourism economics, it's not easy to find their place. When you are in an economics conference, you put a special session about tourism economics at the end of the conference or at the beginning at 9 o'clock when all the people is not there. But anyway, let me confess that when I'm in a tourist conference, it's worst because they looks very strange. Oh, economist, economist talking about tourism. I'm going to understand nothing what about to say. So it's not easy for me to find my best location. So for me today is an honor to be in a plenary session talking about tourism economics. Let me tell you what I'm going to tell you about. I will start with my introduction. I will try to motivate you, and then I will show you how I have been motivated, not only your motivation, how I have been motivated to make this talk today. I'll show you our theoretical underpinnings when we talk about tourism demand model, statistical models about how to evaluate the effects of climate change on tourism. Then I will extend my analysis and not talk only about economists. I will show you how can we evaluate the effects of climate change on tourism demand. But I will show you how other fields like natural scientists or geographers has also evaluated. I will show their results. And then I will center my attention to the controversy because I will show you that, well, be careful in what kind of message we can give about the effects of climate change on tourism, especially for my region, the Balearic Islands, Mallorca, and Algarve. And then I will present some conclusions. Well, let me start with motivation. Let me show, well, I think we are all aware about how Northern European tourists go to the South Europe. You have two pictures. In the right-hand up picture, you have the international tourist departure for every 1,000. As you can see, the black colors are on the north. And here in the bottom one, you have the share of tourists in total GDP. So it is clear that northern people travel to South Europe. There is a clear idea about the climate is a factor explaining these movements. And when you see the prediction of what will happen with the temperature, well, it's easy to understand why people is worried about what will happen with tourists, okay? Well, first of all, I would like to, well, we are economists, and first of all, maybe someone is a skeptic about what about the climate change? Well, that is something that I don't believe in natural scientists. If this is your case, let me put two examples. Well, this is an anecdotal one. Well, Joao and Pedro knows who is Eugeni, is a colleague, is emeritus professor of my university, as he's still working. And 1 year ago, he asked me for the temperatures of our airport, the airport in Palma, for the last 20 years. I'll send him these temperatures. And some weeks ago, he asked me again the same temperatures, and I'll update the database, and I'll say, well, I'm going to make you a graph. Well, don't look at the graph. Look at the numbers. Here you got the average of the temperatures at Palma Airport for every month. And look at this. These are average from 2000 to 2023. And these are the temperatures of the last 12 months. As you can see, the increase in temperatures have been very, very high. On average, the 12 months has been an increase of 1.27 degrees Celsius. So, well, it seems that climate change is here. Well, let me put another example. We are economists, so I suggest do the following. The first time when I was invited to participate in a project of climate change, I didn't believe very much about climate change. But as economists, we have some tools. We can go to for instance, the Meteorological Office of Meteorology of the United Kingdom. Well, this is because it's free, it's very easy to download, and they have a very long time series to download the temperatures and have a look at the graph and try to make a simple regression. Try to regress the temperatures with a linear trend. Don't worry, I'm not talking about integration. No, simply, if you make a regression, you will see that the trend is significant. So there is an increase in temperatures from the 18th century. Okay, well, you can play with this kind of data. You can try to put trends during the last 40 years, and you will see there is an increasing also trend. So it seems clear, as economists, we have tools to see that there is a climate change, there is an increase on temperatures. Now let me show my motivation. I hope that you have been motivated to talk about this. Let me show my personal motivation. To see my personal motivation, let me apologize. I'm going to show you a video of a new that was I watched on TV 1 year ago on August of 2023. I apologize, it's in Catalan, but let me show. It's easy. Portuguese, you'll have no problem.
L'informe de la Comissió Europea analitza la progressió de pernoctacions en el cas que, d'ara i fins a 2100, les temperatures pugin d'1,5 graus a 4. En tots els supòsits, les Balears són el destí turístic espanyol que més se'n veuria afectat. Les illes perdrien un 0,7% de pernoctacions si la temperatura pujés 1,5 graus, i en el cas de que fos de 4, l'ocupació cauria un 8,2% amb 3 milions de visitants manco. Les dades apunten que els climes del nord més benèvols serien els que més es beneficiarien amb d'un 4 a un 7% més d'arribada de visitants. Cantàbria, Astúries i Galícia serien les destinacions escollides dins l'estat espanyol. A nivell europeu, el nord del continent tindria una pujada del 5% en l'arribada de turistes que cercarien climes més frescos, i Alemanya, el Regne Unit, Suècia i Finlàndia en serien els països més beneficiats. L'informe...
Yes. Well, fall. I was shocked when I saw this film, on the news. Well, I have worked with this kind of models I'm going to show you, but this data about a drop of 7 points percentile in the number of tourists, 3 million tourists. I don't know if you have heard, 3 million tourists less than in the Balearic Islands. Wow, they are very huge. This is what journalists want to hear, I thought. But something is wrong here. In fact, let me say, well, this is the report of this is the original report of this new. As you can see, Algarve also is going to lose a lot of tourists, according to this report. What was impacted? I have known the new, but just before to see this new, there was a journalist going to interview some tourists on the street. And this was surprising because probably the journalist was expecting that the tourists said, okay, well, yes, the weather is very hot. On those days, we were at 36 degrees Celsius. It was very hot. We had a heat wave. And probably the journalist was expecting that the tourists said, wow, it's terrible. But surprisingly, they found a Danish tourist that was waiting for going into the cathedral. And he asked, what about the weather? And the Danish tourist said, oh, it's excellent. Oh, excellent? Yes. I have, during the last 15 days, I have been at home. The weather was cloudy. I have to open the central heating, and to be here is excellent. It's perfect. Okay, like the resident, let me confess that I was also surprised. For me, the heat wave was terrible. It was the final of August. We had, I don't know how many heat waves, but this Danish tourist was excellent, was very pleasant. What's the matter? The Danish tourist is very okay, but the model says that he will not come back. Well, let's go to review the models that can provide this kind of results, and let's go to thinking about if these models has something that is wrong or not. Well, let me start with the theoretical underpinnings. I will not go very much in deep, but all the theoretical underpinnings of all the models has a very classical formulation. You have the utility function. This is the utility function of an individual that lives on I, makes a trip to J during the period T. So the function depends on the number of trips that from I to J makes during T, the quantity of other goods, the characteristics of the origin, the characteristics of the destination, and you have the constraint. that is the price of the travel costs of the different destination that you can provide, that you can imagine, and the price of the other quantities is subject to your income. Okay. Well, the problem you have to maximize subject to this restriction, and the solution is to maximize the Lagrangian, and you have the demand functions that I define it in terms of where are you from, where do you want to visit, which is the country or the region you want to visit during the time t, and you can also estimate or imagine that you can calculate the utility associated to your choice. Well, here from this model, you can adapt from different perspective using different models. For instance, you have on the first time the time series model. In this case, we center our attention in the dynamics of the time series. We are on the context of tourist demand model, how to explain different flows of tourists between different countries. Imagine that you have the flow from United Kingdom to Algarve, you have the tourist flow from Germany to Algarve. So you are working with monthly, quarterly, yearly tourist arrivals from different countries. Well, which is the problem of this? Well, we have two problems. With this kind of models, the characteristics of the origin and the destinations disappear because you have a time series, all the characteristics are in the constant term. So if you want to evaluate the effects of climate change on tourism, in this case, the optimal context is to center our attention in high frequency data. For instance, monthly, weekly is possible, daily if it is possible. In this case, I'm not talking about probably climate issues. I'm talking about meteorological, extreme weather events. I will show some example. And the context will be the transfer function model or the REMATS model. Well, let's now to the discrete choice models. We are using the same underpinning, the same theoretical underpinning, but in this case, we center our attention in the individual choices. So you have different individuals making choices about where you want to go to visit. Well, in this case, we have to change a little bit the economic background. In this case, I suggest to go to the Lancaster model that is more, this is a usual framework for environmental economics, where the source of utility are not the commodities by themselves, are the characteristics of the commodities. In general, commodities and services have more than one characteristics, and combination of commodities and services can provide different utility than the same group of commodities and services individually considered, but we are not going to go in deep in this third, that is problematic one. Anyway, let me see an illustration of this model and how this works. Let me illustrate. Imagine that we have three destinations, A, B, and C, and we have two features, two characteristics, the temperature and cultural facilities. In this case, these kind of models assume that these are the destination, are axes, different axes. When you select a point to visit one destination B, you have this amount of characteristics of this temperature and this amount of other facilities. Here we put the income restriction or the temporal restriction, it doesn't matter. This is the maximum that you can get from every destination. Here you got the indifference curves, and here are the optimal, the selection of this individual. Well, if climate change becomes, the temperature will change, and this means that this axle will change their slope, and the choice can change. Okay, it's very easy to understand from this kind of models. Well, you have now to parameterize this kind of models. The point is that we parameterize the utility, and if the utility of your choice is higher than the other one, you have to parameterize this kind of probability function that we have standard rules today in the econometrics programs. Then we have the aggregated models. The aggregated models probably are my preferred one. It's the ones that I have worked more. Well, are my preferred ones because they give you a very global picture, and this is what generally people want to hear when you talk about climate change. Well, the underpinning is the same, but in fact, we only look at cross-correlation between macroeconomic variables. That's all, okay? The underpinning is the same, but we look at cross-correlation between variables. So we should be careful with this kind of models. Well, This is our underpinnings of from economic point of view. But let me confess that when I'm in a tourist conference, I found different alternatives. I find different natural scientists. I find geographers. I also find economists. How can they evaluate the effects of climate change? Well, first of all, the natural scientists have nothing to say. They give me information about situations like this. They give me which will be the amount of snow melt water in a ski resort. Okay, they made their predictions, they use their formulas, and they give you the results. I will show you later, only as example. Nothing to say. Another question should be, for instance, there are some people in my university that works on what about which will be the sea level rise? What will happen with the beaches if the climate change becomes? Well, they study situations like this. Nothing to say as economists. Okay, this is information that go to the tourist managers, and I assume, they can manage these situations. Then we have the geographers. Well, sometimes you can find some economists. They often use what is called the tourist climate indexes. Well, for me, this is very special because then the tourist climate index is later. Well, I'll show you how these tourist climate index are also incorporated in tourist demand models. So it is very important to know very much in deep how they work. Well, let me see that the tourist climate index was proposed by Miekowski in 1985. Nobody talked about climate change in those years. Well, the idea is that, well, tourists not only move for temperatures. When you want to visit some place, okay, temperature is important, but it's also important. The humidity is also important. The wind, the precipitation. There are other meteorological variables or climate variables that are important. So Miekowski combined. They propose an index trying to combine different meteorological variables, for instance, daytime thermal comfort, sunshine, precipitation, and wind. As you can see, the temperature is the most important one. And, well, we are familiar with indexes as economists. So they give values from 0 to 10 in reference to, for instance, the sunshine hours. If you have a lot of sunshine hours, the tourist climate index will be higher. If you have no precipitation, the tourist climate index will be higher. Here you have the relationship with wind. In general, when there is no wind, the tourist climate index go up. And finally, of course, you have the relationship with, well, humidity is the temperature combined by the humidity. Is the sensation. You know, when the weather is so dry or wet, is different to compute for the temperature. And they, in reference to different temperatures, they give you a value. Okay. Well, I'll show you later. But look at this. When you are very high, the TCI is very low. Okay. Well, we will discuss about this. But anyway, what we get, keep in mind, I insist again, Miekowski don't talk about climate change. They want to explain which is the distribution of the tourist flows around the world according to an index of climate. And they use this scale, telling that if the TCI is between 90 and 100, it will be ideal. It is a bit lower, excellent. Well, they give names to the different values of the TCI. Well, as I said, be careful because the TCI is a special relevance because they use as a determining variable in demand model is usually frequent. And we will go back later. Well, how to evaluate the effects of climate change on tourism? I have said, as economists, we have three main contexts where we can evaluate, and I will show you some results. Let me show some results, okay? Results. I will use the same three contexts. The context on physical environmental, these are the natural scientists. Well, they give you projections about snow conditions at different sky resorts. Okay, excellent. They give you projections about the sea level rise. What will happen with the sea level rise? Will it increase 1 meter, 20 centimeters? Okay, they'll give you projections, and this is information that can be useful for tourist managers. Then we have the use of tourist climate index. Here you got a paper by Amelung, Nichols, and Wiener. that they project the tourist climate index. Well, project no, they estimate the tourist climate index for 1970, and they project the tourist climate index for 2050. Okay, as you can see, the north of the, well, Canada, Russia is more. It seems that is more pleasant. It's more pleasant. The climate will be better in 2050, and other places in the world, for instance, if you look at the Iberian Peninsula, will be worse. Okay, it seems that we are going to lose attractiveness in terms of climate. Well, if we can center our attention, there are other projections. For instance, this Hein et al. Look at the Europe. As you can see, it seems that climate change are bad news for Balearic Islands, for Spain, and for Portugal, especially for Algarve. As you can see, this is red. That means that it's very hot. It's a pleasure region to go on tourism. However, if we look at the projections for this period, we are going to lose attractives. Well, good news in spring. In spring, it seems that we have more tourists. Well, more attraction. Let me see then if we can link with tourism. But these are the projections. And let me finally show a very catastrophic apocalyptical projection of my region. In black, you have the number of nights spent at my region. As you can see, there is a clear seasonal behavior. Here you have the tourist climate index in 1970. This is the one. It fits very well. But the projection of the tourist climate index for 2018, I think, 2018, okay? Yes, they look that well. During summer, it will be too hot. Well, it contradicts. There is a contradiction with the Danish tourism, I think. But anyway, this is what the kind of models show you. Okay, evaluating the physical condition and climatic stability is nice. However, as economists, something is missing. Okay, quantitative assessment of the consequence of tourism. I want to evaluate how many tourists. Okay, this is attractiveness in terms of a very romantic point of view, but how many tourists? How many GDP? Okay, we are economists. Let's go to use the demand models. Okay, let's go start with the demand model using time series. Well, the first problem that we have when we have a time series about tourism is we have a seasonal behavior, a strong seasonal behavior. We have to delete him, and let me show the example of one of my papers that we look at the impact of weather variability of British outbound flows. Well, the red line is the number of tourists going abroad from United Kingdom. Okay. The green line is the fitted using a standard ARIMA model, and the blue line are the residuals. Okay. So, which is our hypothesis? Can this irregular behavior be linked to by irregularities in the meteorological conditions of the origin destination? Well, let's go to test it. Let's go to collect data about United Kingdom outbound flows. Let's go to take information about mean, minimum, maximum daily temperature, days of air frost, rainfall, degrees at setting, 16 degrees, heat waves, cold waves. And what we found, I was skeptic, but when I see these results, I was very surprised, is that when you use a simple ARIMA modeling, you get these statistical results. Well, these are, for instance, let me center my attention in the R squared. But when you introduce lags of the meteorological variables, your statistics improve very much. So it seems that these irregular components explain why people go abroad from United Kingdom. Well, this is something that I have heard in my region. Sometimes say, okay, the market, British tourists don't come because they have a very good weather there, or they come very much. The market of United Kingdom this summer is very good because they have a very bad weather. So we statistically test this, and we found that there is a relationship. Well, this was the relationship between the variables. And what we make is, let's go to make a simulation. Let's go to take our data, and let's to replace the temperature by another variable, that is the temperature plus 1 degree. And let's go to see what happens with the model. And what we found is that if we increase the temperatures in the United Kingdom, the number of tourists from United Kingdom traveling abroad will drop 1.7%. 2 degrees, 5%. So it seems that if temperatures in United Kingdom go up, people from United Kingdom will have less propensity to go out, okay, to go travel abroad. Well, let me put another example that we have. We look at Mallorca Google searches. As you can see, Mallorca Google searches is a very seasonal variable. All the people look about Mallorca during summer, but in winter nobody comes. Well, let's go to see if Mallorca searches from Germany and from United Kingdom can be related to the meteorological variables of United Kingdom, in the case of the United Kingdom time series, of Germany meteorological stations, in the case of the variable of Germany, and also the temperatures and rainfall and average temperature, rainfall and wind of Mallorca. Let's go to see if there is kind of relationship. Well, the statistical model doesn't work very well. In the case of United Kingdom, outbound flows, it worked very well. In this case, it doesn't work very well, but we found that when British and German has good weather condition, their interest in Mallorca seems that is lower. And when the weather in the origin country is also very bad, their interest in Mallorca is higher. Okay, the point is that Google searches, you can have information at weekly level. For this reason, we make this exercise. Well, let's go to the second context. Let's go to talk about the discrete choice model. Let me show you the example, the model that Eugenio Martin and Campos Soria published in Tourism Management in 2010. Well, they make a model trying to explain why European households travel abroad, travel domestically, or travel both. Okay, they try to explain why people travel to other countries or travel only domestically. Okay, they make a model. Well, they use the typical socioeconomic variables: income, number, age, number of people in their household. And they use as a meteorological variable, they use the TCI. Okay, I have said we have two options. One option is to use the tourist climate index. The other one is to use directly temperatures. Well, they use the TCI, and from my point of view, one of the interesting results is that they found a very, very similar results of us or our model of time series, but using a very different methodology. The similar result is this black line. This black line gives you the probability to travel abroad and is referenced to the climate index. The idea, as the temperatures go up, traveling abroad will be, traveling domestically only, will be more probable. This is very similar that we found for the British market. If the temperatures go up, people remain at their home. Okay? Let me give you a second example. We make an estimation about domestic tourism traveling domestically. So this is the discrete choice models for people traveling domestically, for the Spanish residents, traveling to the coastline. We use travel codes, beach characteristics, climate attributes. We use temperature and squared temperature because from the literature, I will show you the first models. We know that the relationship between temperature and tourist demand is not linear. So we use temperature and squared temperature. This is an important issue for the controversy. And we project what will happen with the domestic tourists in Spain during summer traveling to coastline. And we project for the different scenarios of climate change for the previous report of the IPCC. And we found what we expect, that the north regions of the north region of Spain will lose market, not tourists. We don't like to, in my case, I don't like to work with data because, well, I will explain why. But the share will lose. Well, no, sorry, in the north will gain market, of course, and in the south will lose tourist market share. Well, let's go to the aggregated models. The first one is probably one of the most. It was published, was authored by by Richard, is the Hamburg tourist model. It's a very simple one. He simply want to explain the total arrivals in terms of different macroeconomic variables, like, for instance, area in square kilometers, temperature, squared temperature, length of coastline, and the GDP, isn't it? I can see, yes, per capita. Arrivals, well, GDP at the destination is a measure of development. Of course, if you travel to a country where you have a high GDP, probably have good sanitary conditions, it will be security. And then he may also a model to try to explain the partners, again, in terms of temperature, squared temperature. This was number of border countries, the income, and the area of square kilometers. So they estimate these two models. These are the results. As you can see, the temperature and the squared temperature are significant for both equations, and they project what will happen in the future with 1 more degree. Well, the results, again, as expected, the North will benefit from the climate change. The traditional destination will lose market share. They use the same idea. I'm not going to project the number of tourists, I'm going to project the share. One important result, when you look at the projections of the Hamburg tourist model, look at this. Let me, for instance, well, I know that is 2025, it's old-fashioned, but if you make this model nowadays, I will show you an update of this model, you will get the similar results. What is important is that when you project, for instance, let's go to central attention in Spain. Okay, in 1995, our market share around the world of international tourists was 7%. And with the projection of 2025, the market share is only 4.84. But look at this. This is the projection using different variables. If you project the market only projecting population for 2025, Spain remains relatively at the same place. When you include the economy, how the economy of the world will change, wow, we have a very significant drop. And look at the difference between these two columns. It is very marginal, it's not very big. Spain goes from 5.09 to 4.84. Which is the difference between these two columns? Climate. As you can see, the market share of Spain will change very much. But climate, the role of climate is not as big as other ones. What we have in the market, probably in the world market, is that during these years and nowadays, Asia is growing very hard. So Asia is growing very much, but not for climate reasons. It's growing because their economies are going up and going up. And this affects the share of tourism. When you include in this kind of models the climate, okay, we can see that there is a change, but this change is quite marginal. Okay, so the first message, okay, climate is important, but be careful. The dynamics of tourism depends on multiple factors, and climate is only one. It's not probably the most important one. Okay, this is the first, well, not the first, an important finding of this kind of models. Well, here you have the same table. Well, this one is in terms of arrivals. This is the share of departures, but the results are very similar. If you compare these two last columns, there are not very significant differences. So that means that climate, well, it's important, but it's probably not the most important factor explaining the tourist demand dynamics around the world. Well, let me confess that we make a very more complex model. We take the Hamburg tourist model. It's very simple, but it works. So we would like to complicate this model. We use not total arrivals. We use arrivals from one particular origin to different destinations. So in terms of, we use all the matrices, and we use the matrix for different years, but we update the data, and we find very similar results. Well, of course, we again use the temperature and the squared temperature at origin, at destination, temperature and square temperatures, and our results were very similar. Although our model was more complex, more econometrically, more sophisticated, we get very, very, very similar results. So I'm not going in deep in the results because we're very similar. Well, finally, let me center my attention about the results, about the report that I have shown you on the news. This report was published last year, and want to analyze the regional impact of climate change on European tourist demand. Which kind of model they used? Well, it's very similar to the model that we have used. They used a model where they try to explain the number of bed nights, tourist demand. We used the number of tourist flows, number of bed nights. You know, it's very similar. They used the TCI, tourist climate index as explanatory variable, and of course they use other control variables like regional GDP, prices, tourist typology, the different typologies of tourism. If the destinations is more specialized in urban tourism or coastal tourism. These are the regression. Of course, TCI is an important factor. And these were their results. Okay, they project what will happen. Ceteris paribus, nothing moves. Only moves the temperature, and of course, the results are very bad news from southern. Well, I'm not sure it's bad news because we have a period of massification, but anyway, the change in the number of bed nights can drop up to 9% in southern Europe. Well, let's go to the controversy. The controversy is, what is the relationship between temperature and tourist demand? The TCI itself and demand models using temperature and a squared temperature or the TCI as dependent variables seem to point at an inverted U shape. Okay? Well, if I collect all the models using temperature and a squared temperature, you will see that the temperature, the variable of temperature has a positive sign, and the squared temperature is a negative sign, the parameters. So that means that we have an inverted U shape, something like this, okay? It's easy to prove it. So we can find the optimal if you want. Using the TCI, remember, the TCI is something that someone in Miekowski in 1985 proposed, and nobody has this, well, not nobody, a lot of people has discussed it, but it seems that economists are not aware about this. We are using the TCI, says that, look at this, when you are at 31, 32, 32, 33, you are losing attractiveness. The TCI gives you a value 1 or 2. 2 days ago, I was at 36. Do you feel that I score the temperature, or many tourists that come from Northern Europe will score 0 the temperature in Algarve? Do you think that to be at more than 36 is the same that to be at -6? We can ask my Danish tourists, but I think no. Okay. This is my proposal. This is what models made. But this is what I feel my Danish tourists think about. When he escapes from the Danish weather, he comes to Algarve, he comes to Mallorca in order to be hot during 5 days. He remains in an hotel, they have air conditioning, he can sleep. Not as me, I am a local, I'm very tired about my heat waves, but he's escaping from bad weather, from cloudy days. So my proposal is that it doesn't mind if the temperature is 25 or 35. That's fantastic for him. Well, if we imagine that we have this option, imagine that we observe these points, okay? So let me ask you a question. As economist, you are familiar with these kind of things. If you try to make a regression, which do you which linear form, which mathematical form will give you better results? A quadratic or a linear? Well, it seems clear, isn't it? But anyway, let me put an example out of context. Let me put an example of the share of dietary energy derived from protein versus GDP per capita. This is, in general, how many meat you eat in your diet. Of course, if you are a poor country, you cannot buy meat. But when you have good GDP, you can eat all the meat that you want. But if you have more GDP, you will not decrease the number of meat that you eat, isn't it? It's something that when you have a level, this level keeps you. Okay? Well, but when you make a regression with this data, the using a quadratic gives you that you get better results. Which is the message? The message is that we should be careful. If the relationship, to have a non-linear relationship, doesn't imply that the relationship is inverted U-shape. And be careful, using a quadratic form imposes that you have an inverted U-shape. And when you try to predict the stem, the end of the tail, be careful. You are predicting these numbers. Well, but which is the relationship? It is inverted U-shape. We are doing well. But in the case of Danish tourism, you are not doing well. You should be careful in predicting in the scenario of climate change when we are predicting hot destinations, because we are not sure if the relationship is like this or is like this. If the relationship is like this, using a quadratic relationship will give you your overestimate the damage of climate change. Well, let me jump to the conclusions. Well, there is a positive relationship between climate and tourism demand. I think it is evident. In the right hand of the distribution, I think nobody can discuss about this. So in the context of global warming, could be good news for seasonality. For instance, probably it's an industry to capture tourist flows during spring, during autumn, in those regions that were cold some years ago and will be warmer during next years, during next decade. What about the domestic tourism? Well, you probably will increase in colder countries and redistribution in warmer countries. Okay, it seems also clear that, well, northern countries will remain at home. Is global warming bad news for hot destinations? Well, I'm not sure. Let me confess that I'm not sure. It is true that probably now people go to Balearic Islands, go to Algarve, and maybe in the future we'll also go to Galicia. Maybe our share we will lose. But for me, it's very difficult to believe that we are going to lose tourists because it's too hot. The message that it will be too hot for going to Algarve or for going to the Balearic Islands, I don't believe this kind of messages, although journalists like very much to give this kind of news. Should be careful because we don't know, I'm not sure about which is the relationship that describes better this kind of points. It is clear that is a non-linear relationship, but a non-linear relationship doesn't imply directly an inverted U-shape. So we should be careful when estimate with this kind of models. It is true that different segments with different climate sensitivity, more research is needed. I have put the example of the Danish tourism, but when I talk with some of my colleagues of the rest of Spain, they say, wow, I was in Mallorca last summer and it was very hot. It depends. It depends. We have a lot of tourists that they are escaping from cold weather in the north of Europe, other ones, they are not escaping. So we should be careful. Also, it is important. I have talked about, I have centered my attention in Algarve tourism, in Balearic Islands tourism, but what about city tourism? Well, city tourism, maybe it will be too hot for going to Barcelona or Madrid during summer. It is different. And what about induced effects? What about biodiversity loss, dry episodes, beaches transformation? Well, here we have a field of research that more research is needed. And that's all. Thank you very much for coming and for inviting me. And if you have any questions, I will be happy, if I can, and I know, respond it. Thank you very much.
So, after this very inspiring talk and the good news that the Algarve may not lose tourists, we have time for a few questions.
Thanks a lot. Thanks a lot for your presentation. This is just a minor comment, but somehow you touched on this topic in the last part about this JRC report. I mean, I had the chance to read this report recently, and one thing that I find is, I mean, we should not trust the results in the sense that the regression specification that you used, and you were very critical about the PCI. I mean, we should avoid using composite indices in regressions, and their specification does not account for, I don't think, maybe it's country or regional fixed effects, and it's also not clear why they use overall inflation instead the price level targeted to tourism services. And what they do is that they estimate this model in what climate scientists call current climate in sample. And then they extrapolate this with ensembles, which is a fancy word for model averaging, throughout the century. So, and they come up with this very maybe negative impacts on tourism overnight stays, which is the left-hand side variable. I mean, as you said, they estimate these elasticities and they take it forward. And we should be very critical about this report and the results and these fancy maps about the impact on climate, on tourism demand. This is just a minor comment, and I'm pretty sure that you agree with.
Thank you so much.
Topic. Thank you.
Let me confess that I have had the opportunity to talk and to share some experience with the geographers who work on this kind of indexes, and they are also very critical in the use of the TCI. They are very critical. I think the problem is that economists are not aware about this. So we are using the TCI in our models. No, be careful. The TCI was designed for one proposal that is different from climate change. So you cannot still using the TCI. There are other indexes that are better. There is the beach climate index that was developed. There is the urban climate index. There are other indexes, but I was very surprised when I saw that the report of the European Union, okay, is someone who is expected that they are going to use something more robust. They were using the TCI, and when you go to the TCI, you find that the underpinning is this. They are telling you when the tourists are at 32 degrees, they say the same, that they are at 5 degrees. Please go to someone in the street and ask, what do you prefer, to stay at 32 or at 5? No, I come from United Kingdom, from Denmark, and there the weather is terrible. Here, the weather is fantastic. For someone who comes here for 5 days and they remain in an hotel where they have air conditioning, now to be at 30 seats is a pleasure for him. Okay, thank you very much for your comment.
We have time for one or two questions. We are very close to lunch.
Yes, I think they're hungry.
Thank you so much.
Thank you so much.
Coming.
Thank you, Pedro.
Very inspiring to hear.